the first question. Don't turn it into something that's not, right? It's as simple as, okay, y is equal to you factor that further? You could try and find two numbers that multiply to 3 and add to 2. Are you going to find two numbers that satisfy those conditions? No, it's just a common factoring question. That's it. Okay. What about the next one? I think the next one, maybe just, at least for my eyes, I'd rewrite the question. You're looking for two numbers that multiply to, negative 72. Negative 72 add to negative 27. What do you think those two numbers are? Yeah, right.
Shouldn't that 4 be positive?
Oh, yeah, maybe it is. Okay, thank you. I was right the first time. So multiply to positive 72 and add to negative 27. What do you think those two numbers are? What is it? 3 minus 24. Does that sound right? Okay, so both numbers have to be negative in order to multiply to a positive and add to a negative. Does that make sense? So you can run through your your normal 172, 236, 3, and 24, right? And then you need them to add to a negative, so just tack a negative on both of them, right? So just make negative 3, negative 24, okay? And then decompose the middle term. Okay, so we're going to get is everybody okay? Does it matter how I group those two middle terms? It should work either way. Okay. So what's common across the first two terms? 6x you can remove, right? And you should get 3x minus 4. And then remove a negative 1 from that the second two terms. You get a minus 1. Sorry. It's getting a little small here. Put that up there. Minus 1. 3x minus 4. That's the shared terms. So you get is it okay? Okay. What kind of factoring is involved in the third question? The difference of squares? Do we all agree? Okay, let's do the difference of squares then. How do we do difference of squares? We square root the first, square root the last, and have and write it twice with opposite signs. Everyone agree?
Mr. McCoy,
Yes, Dylan?
it says 21x on ours, and it says 27x on yours.
Who wants to explain it?
The question is wrong because my guy didn't look at the question.
Well, I looked at the question. I thought it was a good question. In fact, were you not here for this whole discussion around fact? Where have you been?
Oh, I was doing math.
Not that math. Okay. So I asked at the beginning of this, Dylan, what would we change about that question to make it factorable? We could change it to 27. Negative 27. Okay. So difference of squares says we square root the first, square root the last. So that's what we're going to do. What's the square root of x to the power 4, though? X squared, right? So we're going to get x squared. And then square root of 16y squared. What's that? 4y. Okay? And we're going to multiply that by squared plus 4y. Okay, with the opposite signs, that's how you eliminate that middle term. That's what turns a perfect square trinomial into a difference of squares. So when the signs are opposite, you get the middle two terms to cancel out or zero pair out. Is everyone okay? I'll half apologize to you. I think you needed to learn that lesson, and I didn't intend for you to learn that lesson, but don't get caught on anything in a test situation, okay? If you're stuck, move on. Do the stuff you can do first and then come back to whatever you can at the end, okay? Okay, relations determine whether or not the relations are functions, okay? What do we think about A?
Yes.
Yes or no?
No.
There's only two options. I've heard both now. So what? Let's
Wait, yeah. I was looking at the wrong one.
A. This one, yeah. A. Is it a relation or is it a function? Yes or no? Okay. What's the definition of a function?
Corresponding y for each x.
Yeah, there has to be a unique y for every single x that you see. Now the clue I gave you the other day is if there's more y values than x values, that must mean that some of those x values correspond with duplicate y's. Not duplicate, multiple y's. Right? That'd be like if I wrote that mapping, remember like the mapping diagram? If I wrote one of those mapping diagrams and I wrote down -3, -2, 0, 1, 2, some of those x inputs would have to map to multiple y values because the list is shorter for the x's. Does that make sense? And so when we saw those mapping questions, if we saw that, we said that that was not a function because we have multiple y's for some given x. Okay? That's a clue. Your list for the domain can't be smaller than the list for the range. But the list for the range can be smaller than the x, or the domain. Does that make sense? Okay, not allowed to have that situation. But if it was flipped, you're allowed to have the reverse situation, where there's more x's than y's. Okay? I don't know how I've labeled these. This is kind of funny, but B's down next. Is that a function? B? It's right below it. No, because we're going to fail the vertical line test at that particular value of x, as well as somewhere in, oh, not that one actually. Maybe just at that point. Right? 2 points here. Going to fail the vertical line test there and there. Right? So, no.
Excuse this interruption. Could anyone who still has not had their picture taken please proceed to the cafeteria? So anyone who still has not had their photo taken, please go to the cafeteria now. Thank you.
What about question C? What kind of graph is that? It's a linear. What's the only exception to a linear graph that's not a function? The vertical one, which would, well, we'll see in a sec. So this is a function because it's just a line. I don't care what it looks like with the exception of a vertical line. They're all functions. Okay. What about D? Function or not a function? Not a function. It fails the vertical line test. Okay. What about E? You know the graph of E. What is that? Parabola or quadratic. Do quadratics have any? That's a question I want. Are there any quadratics that are not functions?
Yes. Sideways.
That's not a quadratic. It's a it's something in disguise, which I think I talked about yesterday, right? It's the reflection of the root x graph. Okay? That creates that sideways parabola. Or x equals y squared, which is a different function, a different relation than y equals x squared. Okay, so that y equals x squared is always going to be a function. And what about f? Do we answer questions with questions?
No.
See, that was a no with a period on the end, not a question mark. Be definitive in your answers. It is not a function because it's a vertical line. Is this a function?
Yes. No, yes. Yes.
It is that's just a horizontal line. Horizontal lines are functions. Vertical lines are not. Okay? Okay, is everyone okay? All right. What is this telling you to do? Bryce?
Find x when y equals negative 2.
Find x when y equals negative 2. So basically when the value of the function is negative 2, solve for x. Okay, so anywhere you see f of x as a piece, you're going to replace the f of x with negative 2. So I'm going to get negative 2 is equal to x squared plus 2x minus 17. How do I solve for x now? This is like day 2 when I gave you the refresher, the CUDA sheet. Owen?
Do you add to
Yeah. So in order to solve, remember we're looking for roots, x-intercepts, solutions, those 4 words, right? So in order to do that, I need to set the equation equal to 0. How do I set the equation equal to 0? Make nothing appear on one of the sides. So I'm going to add 2 to both sides. So now I'm going to get 0 is equal to x squared plus 2x minus 15. What is that? It's a simple trinomial. And it's factorable.
No way.
Multiply to negative 15, add to 2. 3 and 5?
Negative. Oh, she's not.
Negative 3 and 5.
positive 5, negative?
Okay. Same thing. Now you've got me confused. Negative 3 and 5. Everyone happy? So we're going to get 0 is equal to. For simple trinomials, we like simple because as soon as I find the factors, you just write the variable in front of those factors and call it a day. X minus 3, x plus 5. Have we answered the question?
No.
No, you got to find x or solve for x. Is everyone okay? I'll hit pause here. Is everyone okay? Do we have any urgent issues? All I have done is factored. And now I'm just going to do that kind of day 2 recap from grade 10 is solve for x, right? So I'm looking for the 2 values of x that make that left side equal right side. Okay, so what values of x set the whole thing equal to 0? That's what I'm looking for, right? I could do that by going x minus 3 is equal to 0 and x plus 5 equals 0. Okay? Now just get x by itself. Add 3 to both sides. You're going to get x is equal to 3. X is equal to negative 5.
Ouch.
Everybody okay? Still copying? Are we okay? I'm gonna go down. Turn the page over. Okay, again, if you came a little late, this is like you write what I write. You now have solutions when I give you the new one or the old one back. You compare, right? The other thing about this is typically what I would like to have happen is to write the formative and take it up right after you've written it so that everything's fresh in your head and you know what you did where, okay? And hopefully make a few like aha moments in that process, right? So let's go to the other side, okay? I'm looking for the value of the function, the y value when x is equal to 1, right? G of x, what is x? X is 1, what's the y value? That's what that's asking you for. So go find where x is 1 and find where the function is. Where is it?
6.
It's up here at 6, right? Here's x equals 1. The y value is 6. What about when the graph is at, when the x value is 4? Where's the graph at? We'll find x is 4, positive 4. Read down. Oh, there it is. It's at negative 6. Is that right? Negative 6.
How can you read that?
Can we genuinely not read? So if this was a test situation and you wrote that as negative 3 or positive 3, I'd probably be a little lenient there. Because to be quite honest, I didn't realize until after I printed it that it counted by 2 on the y's, and I went to actually check the answers. So it'd probably be a little lenient there, but the 2 looks pretty clear. I don't know if I can necessarily read the 6, but I know it's counted by 2's. Is that fair? Okay. I'll be a little lenient in some instances. I'm not crazy. Okay. Especially if a bunch of you do it. Okay, what about the last one? Not as straightforward as you think it is. And I maybe don't want to ask anybody that was in my pre-IB class. Dylan?
Would it be like all the values on the where y equals 0, so like -2, 2, and 5?
Yes, there's no saying that it just has to be one answer. It's all places, all x values, all values of x where the graph is at 0 on the y. Right? So where's that occur? Okay. Everybody look. Yeah, a little aggressive. It's looking for x when the value of the graph is when the y value of the graph is 0. Does that or does that not happen at multiple points? You write all, because they're all true. They all satisfy that condition there. So it's looking for the x values when the value of the graph is 0. The value of the y value of the graph is 0. Okay, so there's a bunch there. Right? You've got one at -2. Right? One there, and one there. Those, if I wrote out all those points, we'd have one at -2, 0. There'd be one at 2, 0, and one at 5, 0. Everyone agree? All the y values are 0? That's what that's asking for. So you say, okay, g of -2 equals 0. G of 2 equals 0. And g of 5 equals 0. Are we okay? That's usually, I don't necessarily put that on the formative before summative. That's the thing that gets everybody. But this test is going to be hard enough. I don't need to try and trick you. Okay? Or ask you any extending, well, I'll ask you some extension questions maybe, but. Okay? You got to be able to think a little bit. It's not a rinse repeat sort of exercise where I do all the homework and you got to think a little bit. Okay? Okay, what about this? Domain range. Domain represents what? What's domain mean? Yes? All the x values. What are the possibilities for the x values? And the range is what are the possibilities for the y values, right? So we said this is kind of like our circle. Does anybody know what the shape is? Okay. Does anybody know what the adult version of an oval is? Yeah, that's maybe grade 3 back. We go backwards. It's an ellipse. An ellipse.
I like oval better.
It's an oval. It's a long.
Okay. Okay. We wouldn't say the planets revolve around the sun in a oval like. That's weird. No, they're elliptical. The orbital pattern of the planets are elliptical. Well done. Oval off. Okay, so the domain is.
Look at how good those lines are.
Takes on all possible, like all values of x in the real numbers, right? Such that doesn't go below what value? Negative 5. And doesn't go above what value? Positive 5, right? Okay, a little bit different from the circle because the domain and range are not the same. Okay? Similar, but just different. Okay? So I can draw my range somewhere in here. It's not perfect, but we get the idea. Okay? So what value of y does the graph not go above or below? 3 and negative 3, right? So just right, but it can take on anything in that range, right? So that was a good bracket at the end. Okay, do we recognize what the last graph is, just out of curiosity? What its equation is? It's the hook, but its equation would be? Do we know?
Is it the fraction?
No. The y, it's called a hook. It's called a hook. What operation in mathematics do you think looks like a hook?
Oh, square root.
The square root, you see? You see why it's called the hook? You're not going to forget that now. Y equals root x. Looks like a hook.
Wow.
Wow, I know. Wow. It's like magic. Okay, so the domain here, though, just careful with this one. Not that it's crazy. Domain. Are there any restrictions on the domain? What are they? Or what is it? Okay. Yeah, that's okay. Yeah, Gwen? Yeah, I'd say just x has to be bigger than or equal to negative 2. I know, you said it a little bit backwards. I just wanted to disagree with you.
No, but that X last week is, because you put the X in the middle there.
Oh, well, that's okay.
X first.
You do you, buddy. I'll do me.
It's confusing.
What about the range? Gwen? Yeah, it's part of the real numbers. Is there a portion of the graph that it doesn't go anywhere? That's not really worded too well. It doesn't go below negative 1. Okay? So again, we just write y has to be greater than or equal to negative 1. That was a good bracket. I'll do me. Is everybody okay? Domain range okay? That's important. That's not going away. You're going to have to be able to, like, in grade 12, you're going to start describing the end behaviors of graphs. Yeah? Owen? Oh. Okay. Owen asked a good question. Yesterday we discussed,
It's like translating.
I'll do me now. I'm teaching. I'll do me. You do you. You're a student. Owen asked a question. Yesterday we talked about how the graph couldn't be in the negatives, this one. Remember? So what's happened? Let's think about quadratics.
Is it translated?
We can translate graphs. This is good for you, yeah? I'm glad you're paying attention. Okay. Okay, I'm doing it for you. So the equation of this graph would be something like this. Specific to that one on the grid. We took the original, just like when you did quadratics, we took the original, we translated it left 2 units and down 1 unit. We are doing the exact same work in this course that we did in grade 10 on top of the other 4 functions. So we've got 3 functions. Okay? The one I didn't show you yesterday was the exponential, but I think you've had some experience with that. We have a whole unit with exponentials again. Okay? Is Is everybody okay? Okay. Evaluate the function at f equals 0. We should see negative 2 times 0 squared plus 3 times 0 minus 8. So f at 0. What is that? Yes, sorry, Sophie? Yes. What is that represent on the graph? There's a specific name for that. Oh, don't yell it out loud. Let's have everybody a chance to think about it. I'm going to ask you about this many, many times over this course. What is that? It's a specific point. There's a name. Let's see what Dylan's got. Dylan said the constant. What does the constant represent? Ricky? The y-intercept. It's the value of the function when x is equal to 0. That's the y-intercept.
You ate it? You just making a new bet.
It's negative. I smashed you over today then.
What do we get? Allie? Say that again.
At the top, you replace the x with negative 3, with negative 2 instead of negative 2.
Oh, sorry. Thanks, buddy. Yeah. What do we get? That should be it. Listen, there's a reason why we put this on here, because the little things like that come up.
Excuse this interruption.
Right.
This is the last call for any photos.
So negative 18 take away 9 is negative 27, and then take away another 8 is what?
School pictures. Thank you.
Negative 27 take away another 8. Negative 35?
Negative
Dill?
35.
Thanks. It was good, buddy. Good. Okay, evaluate this. This is here intentionally because we just want to recap how to deal with exponents on top, like expanding something. Okay. Okay. I do that okay? Okay, and the same thing here, just evaluating. Taking a function, putting it inside of another function, seeing what it spits out. Okay, go on. Is that one factorable? Two numbers. It didn't say consider it determine and simplify. It didn't say simplify, so I'm okay leaving that there. Could you find two numbers that multiply to 64 and add to 6? Is that possible? I don't know. I haven't put any thought into that. Ricky? Oh, we could common factor out of 2. Make it a little bit easier. Yeah, anyway, that wasn't really the point of the question, but okay. If I want you to do that, I'll say whatever, determine this and fully simplify. Okay? Okay, what about the last one? Should see negative 2 times x plus 2 squared plus 3 times x plus 2. Okay, we haven't really explicitly gone over how to expand a binomial times a binomial. We did that probably to death in grade 10. So we're just going to do it here, right? Okay, it's important to follow bedmass here too, right? Doing any work inside brackets before you expand in. Following the exponents first, then inside brackets, then the multiplication, then the addition subtraction. Okay, you always keep bedmass in mind when you're working through these. Okay, so we're gonna get I think some of you probably combined these before you've expanded the 2 in, maybe. I've seen that before. Is everybody okay? I'm going a little quick because I just want to wrap it up, but you're going to collect all the like terms, add them, subtract them together. Should have one final expression. Okay, and we should be good to go. I think I'm okay. I don't think I've done anything wrong yet. Okay, so we should get something like negative 2x squared. Negative 8x and 3x should be negative 5x. And then negative 8 take away 8 be negative 16 plus 6 should be negative 10. Okay, that would be the value when I evaluate x plus 2. Value of the function when I evaluate at x plus 2.